video we're going to see about digital signature and hashing. First of all, let's see about digital signature. This is nothing but it is more like a normal signature which we write on a pen and paper, whereas it is used to verify the authenticity and integrity of the documents digitally. Nowadays, attackers tamper the data and modify the data and proves it is legitimate. To avoid that, digital signature are introduced. It is introduced by MIT. Then here we implement this by using a Cryptodome model, which is Python model. We can import it and use it. This digital signature, they use private key to encrypt the data, and whereas the user verifies the data for this authenticity and integrity by using the public key. Here at the code, here in this code, first I will generate the key. I use RSA algorithm, RSA encryption algorithm to generate the key. Here I generate 2048 bytes of key. Then I export that key and save it as in private key variable. Then I store the private key variable data in a file called private key. By creating the private key private key file and insert data in using WB mode, that is write binary mode, and after writing I close the file. Then similarly I create the public key also. Similarly I open I create one file public key with write binary and write to it. This is the message I want to encrypt. This is message from me. The key here what I do is I first using RSA.import key method. This import key method is from RSA class, which is present in Cryptodome library. I just open the private key and read the contents and save it in key variable. Then what I do is I just hashing the my message using SHA-256 algorithm. Then using this PKCS 115 class, that is the new method. I just create the object here. I then use that object to sign and save and sign my hashed message, that is H, and save it in signature variable. Then I just print it here. Then I just save my signature to the file using file out using the same method we used above, by opening by creating a file in write binary method and save it there. Then I also saving the my message message, that is this plain text message in file using same method. This is in the part of signer. This is where the publisher signs the message and sends to the public, sends to internet, whereas the users verify the message by using some methods, some mathematical calculation here. I already told that they uses private key for encryption and public key for decryption. Here they uses public key. Here I just import the public key file and read the content which I created in this step. Okay, you can see that I just use the private key to encrypt the message here, whereas in this part I use the public key. In this part the normal user doesn't know the private key. Then I just open the message file, that is the text file which contains the actual message in RB mode. RB here is read binary, and I just read in and save it is in message variable. then I open signature PEM file which I created in this step. You can see that. And open it in re-binary mode and save it in signature variable. Then what I do is I just SHA-256 my message here. Then after that I just compare. After that I just using this PKCS of 15 class method new method and by passing my key, that is public key here, contents of public key here, and verify by passing my hash of the message and the signature. If it matches, then the signature is valid. If doesn't, it doesn't valid. Let's run it so you can get better understanding. First run my signer file. This is 1 minute. This is the file. This is the directory which my program contains. There is no other file excepting this program. Let's run it. Just give run. I just open terminal and run. I just run the file. Let me zoom it. Yeah, you can see that I just print the X of the signature here. Okay, let's you can see that some files are created. You can see here also. Then you can see, yeah, these are the files created. The message.txt file is the actual message. This file contains my private key. This file contains my private key. This is my signature file, that PEM file. Let run my verify script. You can see that the message signature is valid. Yeah. Let's suppose I just simply put dot. Okay, I didn't do any much changes, or I just give one space here, nothing. Or you can do any changes, even the changes, a small changes also reflect. Then I just run my script. It shows that message is not valid because I just edited the file so that the integrity lost. So that it is not as invalid. You can see this type of signature in real time, like when downloading Aadhaar from UID website, where you can get some digital signature. When any attacker intentionally, when the attacker needs make it the file edited. The digital signature cannot be verified because the integrity of the file is lost. The digital signature helps in providing the integrity as well as the authenticity of the message. From who we get the message, like that information we can get. That's all for digital signature. Let's run our another program. Yeah, hashing. Here I just give a small demo here by this simple program. I just use one similar method from Python, that is hashlib. I just create two methods. Hash word. This is when I give this. This is the message which we want to hashing. Which we want to hash. Hash is nothing but it is a one hash. It is a one-way function. This hashing can be done to make the file of one length to a certain bit of length as the output. mostly you can see this type of hashing can be used in database when saving password. For example, when saving password, they use some hashing algorithm and save it in database. Even if the attacker can get access to the database, he cannot read the actual password of the user, because it is hashed. I already told that hashing is a one-way function, so the attacker cannot, it is very difficult for the attacker to decode to get the actual text from the hashed text. Okay. This is the for example password. This is the word which I want to hash. I just use hashlib class and uses MD5 method. Which simply made MD5 hash of my message. I encode the text, and on pausing this you can get that the hashed message of the the hashed output of my message. Okay. Here also same, where we can also hash files. Why reason we hash files is in digital forensics like things, the integrity of the file must be proven to the court of law, so that the crime so that the person who did the crime can be proven as accused. So that in digital forensics like things, they hash the files, and they can get the hash value and before and after analyzing the evidence. They just compare to make that the file is analyzed properly. Here I just I just get the input as the file name from the user, and I just open the file in read binary method, in read binary mode of file opening. Then I just read and save it as in bytes, and I use that bytes and pass this parameter for MD5 function, and passing it to hash. This is, you can get the hash of the files. Let's run it. Python hashing. You are going to get that for the hash of the word password is this. Then it asks for a file name. Just give the file name public key. Okay, for this table public dot key. Okay, you can get the hash of the file also here. That's all for this video. Thanks for watching.